We're going to end off this week by talking about one specific kind of energy called kinetic energy. So here's the definition for kinetic energy. It is the energy associated with a mass in motion. So if you have any object that's got some kind of mass and it's moving, then it has kinetic energy. The formula for it is shown here. Capital K is going to be our symbol for kinetic energy. And it's going to equal to a half times the mass of the object times the speed of the object squared. Mass needs to be in kilograms and speed needs to be in meters per second in order for this formula to work. And after you calculate it, the units for the answer for kinetic energy are going to be in joules, which is the exact same unit as work, which we did earlier in the week. And that might be kind of surprising because work was force times displacement, so newtons and meters, whereas kinetic energy is mass times speed squared, so kilograms and meters per second. So it might be kind of strange why those would have the same units in the end. I'll have a separate video to explain why. That'll be an optional video just for those who are interested in why they have the same units. Okay, one thing to note is that kinetic energy is a scalar quantity. So you do not put a direction for kinetic energy. And the speed of the object, v, it does not matter what direction that speed is. Okay, so with this formula, I'm going to point out two statements here. So K is proportional to mass. So in the formula, K equals a bunch of stuff, but there's mass right there. And everything's multiplied together. So that means that, for example, if you were to double the mass of an object and keep everything else the same, then the kinetic energy is going to double. If you triple the mass of the object, then the kinetic energy is going to triple. So that's what proportional means. But then what about speed? So speed is squared in this formula. So the statement I write is that kinetic energy is proportional to the square of the speed. So now this time, if you double the speed of the object, then what happens to the kinetic energy? Well, if you double the v value, the effect of that gets squared. So doubling squared is really multiplying by 4. Okay, so you double it twice. That's like multiplying it by 4. So if you double the speed, the kinetic energy will get multiplied by 4. What if you triple the speed? If you triple the speed, but that effect is squared, so you triple it twice. So that's multiplied by 3 and multiplied by 3 again. That's like multiplying it by 9. Okay, so if you triple the speed of an object, the kinetic energy is going to get multiplied by 9. And I want to try to show you those things through this big table here. So what I've done is I've calculated the kinetic energy of an object based on these masses and these speeds. Okay, so in this first box right here, I would calculate K equals half mv squared for a 1 kilogram mass and a 1 meter per second speed. But actually, I'm not starting there. I'm actually going to start in this box right here. Okay, so if I plug in 1 kilogram for m and 2 for v, then it's going to be half times 1, which is just a half, times 2 squared. So that ends up being 2, and the units are joules. Okay, then I'm going to go one column over here. So now it's going to be at the same speed. Okay, so still 2 meters per second, but instead of 1 kilogram, I'm doing 2 kilogram. So all I'm doing is I'm changing the mass. Okay, so I do the exact same calculation, but now the mass is doubled. And if I put a 2 here, so it becomes half times 2, which is 1, times 2 squared, which is 4. So then I get an answer of 4. And you should see that the answer to this one is double the answer to the previous one. So because I doubled the mass, I doubled the kinetic energy. And now what if the mass is 3 kilograms and I keep the speed the same? Well, if you calculate it out, the answer is 6. And 6 is triple of our original answer of 2 when we had it at 1 kilogram. And finally, what if the mass is 4 kilograms and we keep the speed at 2? Well, so now the mass is 4 times as much as our first answer. So the kinetic energy is actually going to be 4 times as much as that, which is 8 joules. So that's what I meant when I said that the mass is directly proportional to, the kinetic energy is directly proportional to the mass. Now the speed is a bit trickier because there's a squared there. So I'm going to focus on this column now. I'm going to focus on this column. So I'm going to start up here now. So I'll just plug in the numbers. I've got a mass of 2 and a speed of 1. So it's a half times 2, which is 1, times 1 squared, which is 1. Okay, so the answer there is 1 joule. Now I'm going to go down here where it's still 2 kilograms. I keep the mass the same, but now the speed is 2 meters per second. So I've doubled the speed. So it'll be half times 2, which is 1, times 2 squared, which is 4. 1 times 4 is 4. So now you'll notice that when I doubled the speed, so I went from 1 meter per second to 2 meters per second, I just doubled the speed, my kinetic energy got multiplied by 4. And that's because the speed is squared in the formula. So when I double it, the effect is squared. So I double it twice, and that gets me 4 times as much. So what would the answer to the next row be? So I'm still keeping the mass the same as 2 kilograms, but now the speed is 3 meters per second. So the speed is triple as much as my first row. So what happens if I triple the speed? Well, that effect gets squared. So 3 squared is 9. So the answer here should actually be 9 times as much as my original one. And if you plug in all the numbers in the formula, you'll find that it does indeed equal to 9 joules. And then the last one, which is 4 meters per second for the speed. So that's 4 times the speed. 4 squared is 16. So it should be 16 times as much as the original answer. If you plug in all the numbers in the formula, you'll get 16. Okay, so that's kind of what it means for the kinetic energy to be proportional to the square of the speed. The effect gets squared. So then in the slideshow in the notes, I just give you the full table here. So these are all the answers. And you should be able to notice that same pattern for every row. Okay, so for every row, things should go up by the same amount. But then for every column, it's more of a quadratic relationship because it's squared here. So you can check that out on your own time. Finally, sometimes you'll have to rearrange the formula like you know from all the other units. Okay, so here's just the formula for kinetic energy, but sometimes you'll have to solve for the speed. And if you have to solve for the speed, you just rearrange it, use your algebra skills. This should be what you come up with after you rearrange for speed. Sometimes you'll have to rearrange for mass. So if you rearrange for mass, this is what you should come up with. Okay, so that's just what you might have to do in some problems. But I will make one more point here, which you see the note down below. When I rearrange it for speed, I get speed equals the square root of 2k over m. So what I can say is that the speed is proportional to the square root of the kinetic energy. And the speed is proportional to the square root of the kinetic energy. And then I can ask questions similar to what we did in the table back here. But I'm going to explain that a bit more in the next video. The next video, I'll just show a few problems. And then again, there's the optional video as well to show why the units of kinetic energy are the same as the units for work. Okay, so that's it. We'll see you in the next video.